What's up, guys? In today's video, we're going to be talking about how to make a rational function given some characteristics of the graph. So problems that look like this, where it says to write a rational function with given characteristics. And before we do this, I want to take a quick look at a graph. And we are going to be graphing rational functions eventually, but just for right now, I kind of want to show you what one looks like. This is what a rational function looks like. This function says y equals x minus 1 over x minus 2. Now remember from the last unit, the zeros of the numerator, the things that make the numerator 0, those are what we call the zeros of the function, because if the numerator is 0, then the whole thing is 0, and those are the x-intercepts. Okay, so a 0 of the function or an x-intercept would be the same thing, and they're the things that make the numerator 0. The things that make the denominator 0, we were calling them excluded values before. Those are things that I can't plug in. I can't put a 2 here because I get a 0 in the denominator, and you can't divide by 0. Well, graphically, how that shows up is a vertical asymptote. Okay, this vertical line here at 2, this vertical line at 2, notice that the graph is approaching it from this side and approaching it from this side, but the graph will never actually exist at 2. The graph exists everywhere to the right of 2. Anywhere I look to the right of 2, the graph is there. And anywhere I look to the left of 2, the graph is there somewhere. Okay, I can plug in some x value and get out some output. If I plug in a 1, I get 0. If I plug in 0, I get, whatever this number is, something a little less than 1. But if I plug in a 2, there's no answer there. So we can call this two different things. Sometimes they will say it's undefined at 2, or they may say there's a vertical asymptote at 2. And on the homework, it's going to ask you both of those. If you see undefined at some number or a vertical asymptote at some number, that means the same thing. That means what the denominator has to be. Okay, so here's an example problem. Write a rational function with the given characteristics. It tells you that it has a 0 of x equals 2, and it's undefined at x equals 3. Well, remember, a 0 is something that makes the numerator equal to 0. So f of x equals... If something's going to make the numerator 0, if 2 is going to make the numerator 0, then the numerator must be x minus 2. Because if I were to plug a 2 in there, I would get 0. If it's undefined somewhere, that's referring to the denominator. So if it's undefined at x equals 3, then the denominator must have x minus 3 in it. So you can see you would have a 0 at 2, because that would give you 0 here. It's undefined at 3, because if I plug a 3 in, I'll get a 0 in the denominator. And that's it. And one more example. This one says there's a 0 of x equals negative 4 and 5, a vertical asymptote at x equals 2. So if it has a 0 at negative 4, then x plus 4 must be one of the factors of the numerator, and another factor must be x minus 5. So that if I plug in a negative 4 or if I plug in a 5, I will get 0 in the numerator. Vertical asymptote refers to the denominator. X equals 2 means x minus 2 must be a factor. So this is one possible, probably the simplest function that you could write that would have these characteristics.